Advent of Code, Day 10. Interesting. I'm gonna use this for once. Um, okay. Yeah. Don't have any specific number of those. Okay. Mm-hmm. Wow. Oh, these are okay. I do like that, but mm-hmm. Sure. That took way longer than I should have taken. Hmm? Where are you? You're 43? Really? Oh, right. Right, because that's one past the end. Duh. Okay. That took way longer to get that done than it should have. Mm-hmm. Okay. So what's this? Do we care about that? I don't think we care. I don't think we care. Okay. Mm-hmm. Yeah. Okay. So sure. I don't know what braces are, so and That's for being buttons. Right. Yeah. Okay. That is interesting. For state into do. We shouldn't be cycling. Yeah, why are we cycling like that? State into do. Means I did something wrong. We got that. Great. My target is that. 0 and 2. All by toggling that and that. How about I take that out, I take that out. Hmm? Okay, now I'm just confused. Oh, right. Duh. Oh, that was stupid of me. Okay. If you to increase by 1, great. And it's always increasing, meaning that's actually not bad at all. So I don't care about you, I care about joltage. Um, yeah, so it's that. We still will do this. Number of steps, great. New states, great. State equals list state is great. I think that's right. Oh, maybe not. Maybe it's just taking too long. 4, 5. Okay. Which I think is actually exactly the same, so I wasted time. Anyway, is this at least doing the right thing? It is, that's great. Okay. Is the problem number size? It might be. So you are processing, but you're dying there. Didn't I? This is a graph problem, actually, isn't it? I'm going to keep that running. I can do this as a graph. I can totally do this as a graph. So I have that. Yeah. So I have thinking about it, I can do the other as a... I can do both of these as graphs. Yep, thank you. Mm, I'll do that. Now, the important thing is that for the neighbor function, I take a state. That state is that. For position and buttons, that, this. I actually don't care about you. I don't need to assert, I just need to do this. $33, is that correct? It is. Great. Yeah, I said I wanted a neighbor function. Or wanted a graph. Yep, that's what I thought. But okay. So if I can make the heuristic smarter, so one thing is a question of the total joltage and what my movements are. So I can move my 2 or... So here I can move my, what, 2, 4, I can do 5. So the number of steps is going to be minimum. Okay. What is my... Okay, that's fine. Mm-hmm. Minimum button length is 2 all the time. Heuristic. Now that should still the right answer there. That's total. Oh, see, that's actually already made more progress than this one did. It's already made more progress. Unfortunately, those ones are going to be a problem. So I think I need to maybe make this more aggressive. Yeah. Yeah, okay. Let's let this, oh, yeah. Let's kill this one. But do something slightly different. You can now run in the background. Okay, good. So this is up at that. Uh, okay. Do I want to just try something greedy? Maybe I do. Maybe I want to be greedy. Or instead of being greedy, do I do that sort of thing? Sure, let's do that. Where I take this. I replace this. Okay, that's too much. Sure. Here. was a little afraid of that. That floods the working set extremely quickly. That makes perfect sense. Um, Heuristic isn't helping a ton. Part of it is because I'm cycling back to previous buttons that I've handled. So I think my state. Because it's just a bunch of crosstalk there. So the state is actually going to be, yeah, that. It's just that. The end function is just that. So here, while this should still give me the right answer here. Nope. Okay. Ooh, that's eating up more memory than I'm comfortable with. Why did this break? Yeah, I'm gonna have to kill that soon. Int in tuple. Um, Wait, what? Oh, puristic strong. Um, so what if I... that... Oh, right. Yeah, because you're eating up too much memory. So let's keep that up. Yeah, I was probably just wishful thinking about... Ooh, man, I am missing something. Um... Oh. Oh, that's a good idea. I already have an improvement. An improvement I should have thought of a while ago. Um, okay, that's good. Over here, sort the buttons. Probably won't do any better. So what I want to do actually is yeah, yeah. Okay. So I do like treating this as a graph. What I don't like is exactly how I'm doing this. Um, yeah, this can go away. So there's a graph problem. I was thinking about it incorrectly. Uh, Honestly, sorting that doesn't matter, but whatever. Do I need this? No. Start is that. Um, Shortest path length. Graph to start to joltage. Okay, so neighbor function. What I need to do here actually is um only increase those. So that's the first bad joltage. That's what I need to improve. Valid buttons equals it's a valid button so I can deal with. So and I know it will take n steps. Sure. Do that. Mm-hmm. New states is a set for B. Now this I worked somewhere. Oh, right, right, right. Oh, right. -3. That's annoying. Um, wait, what? Yeah, 3 steps. How in the world? You cannot be. From start to voltage. If all the steps to take are non-negative, how do I get a negative steps? Oh, negative. It's because there is no path. Duh. As my no path sentinel. Um, yeah, 160 is here. And hold IDX. Let's do that for one. Even though it's kind of not necessary with my lazy graph, but sure. Zero 01, 02. Great. Yes. My target voltage here is 3, so I'm going to take 3 steps. For essence states, for being valid buttons, this equals list as add new states add tuple of ns. Steps to take, steps to take. Wow, that's so dumb. Oh man, that's a dumb typo. I want to remove also you. Actually, no, I don't. I want you. I can generate the states themselves more efficiently. What is it about that? Their targets are high. Their targets are high. That's my problem. So this is a combination of vectors. That's great. This is already faster, though. Yeah, already much better. Man, I should have done better. Should have noticed that quicker. Leave you running down here when I am handling generating the states. Yeah. Do that. Generate the states more efficiently. Do. First off, validate with this. So worm states. Where is that? Oh, really, where is that? Steps. Really? That is annoying. Um, do I want to do a breadth first search? So fundamentally what I'm... Is the heuristic harming me? That's a better question. Is it harming me now? So what is it about 0, 1, 2, 3, 4? All of these numbers are big. Should I take the one with the biggest difference and excludes the state space? Should I take the one with the fewest buttons? So here, for example, two isn't a bunch. Six isn't there, it's there, it's... Okay, so it's in one place. 2, 3. 8. 3, 4, 5. Should I be greedy and prioritize buttons that have the most impact? Yeah, that's print buttons. You are the one running right here. You have buttons. Yeah. Hmm. I'm definitely. I did want a graph problem. So fundamentally, what is it here? So I think overall, I have the heuristic. I've got the minimum button length. So 2, I can pump up at will. Do I need to do what has the most constrained buttons? Because that's part of it. 0 has an extremely free button here. And it slows down crazy. So do I need to prioritize buttons that... Okay. Um, the maximum of the minimum what if I do that? If IDX is in B, and I like, okay. So for all of these, I've got to send up belts that are valid. Right. Um, that's just improving that heuristic. Um, oh, wait, no, that's right. Okay. First off, let's go back to this. Sure. 1, followed by 0, sure. Followed by 3, followed by 2. Great, yeah. 1 requires touching at least 3 things, which is the worst overall. Sure, great, yeah. Um, now, really. Oh, okay. Where's my other print? It's a waste of time. Oh, So I'm naturally being greedy. Great. This whole thing is being greedy. Um, I'm just curious, how bad am I doing? Yeah. Oh, hey, only one person on that leaderboard. But a ton of people here. What in the world am I missing? I am sure I'm missing something here. And I feel very dumb and blind. And well, we have a new contender. I have made this sufficiently greedy that it's making better progress than my previous. It's horrible. What am I doing wrong? Actually, I've got a better question. Can I figure out what I'm doing wrong before this finishes? Because this is actually making progress. And my hunch is no. Except I see some giant numbers. Like, even worse. Oh man. Okay, so we're zero index, so 18 is actually this, which has 3-digit numbers. Though over here, what was it here? That has 194. So maybe it'll figure it out. What am I missing? Is it just because I'm doing a graph-based search versus a traditional greedy algorithm? It could be. right? Yeah, 197 total. And it's stuck on this one. Just for my own smallish, another one with 200s. I don't think we get past like the 200-ish range. So what if I, instead of what I'm currently doing, this is a different instance, right? It is. I am currently choosing the worst index based on that. So I thought I do not believe that this is doing any better. I think it is doing worse. Untraded greater than or equal to there. Fine. Yeah. Okay, so the one blowing up was this one. Yeah, this is just a better heuristic. Feels sort of aggressive, sure. I have what? 3 once. That once. That won't do. Sure. This twice. 0, 1, 2, 5 times. As opposed to 1, 2, 3, 4. So this is a red herring. It brings in 4. It then causes problems. I think that might be the issue with this search speed. The horrifying thing is I'm starting to contemplate before I do that. Okay. Okay. So now we're thinking with multi-threading. So it's also beyond horrible. You honestly can die. And you as well. It's got 8 instances. Now, if for some reason you're actually watching this and you're wondering why I'm doing this approach as opposed to using Python's multiprocessing module, it's because my uh, lib.aoc, uh, I'm pretty sure would cause problems with all the get input and all the other calls do rate limiting. Um, and there's other things. The last time I tried multiprocessing, it caused major problems and ended up accidentally just sending a ton of requests to the Advent of Code site and getting me temporarily blocked. I don't particularly want to do that again. So we're sticking with this sort of manual multi-threading, um, which is going kind of well. We have a number of things being processed right now, which is good. How many threads do I even can I safely go to? No, not there. That's performance. No, this is performance. Okay. And those are yeah, those are only logical. I've only got 8 real cores. And I'll add a couple more. Nope, that's it's the absolute worst brute force I have ever done. Um, 19. Yeah, because most of these compute fine. One more. I don't want to go any past that. I'm already really making this poor CPU work. No. We'll do one more. That is the final one. Yeah, I'm annoyed because I am missing some property about this, which makes it reasonable. And for the life of me, I cannot figure out what that is. So 136, 137. So it's actually 137, 138. Those are both not even that big of numbers. Oh, I've got one on 140. Okay. I have a silly idea. Oh, I am going to hate if this works. I am going to hate myself if this works. Um, nope, don't need any of that. I do need this. No view. Mm-hmm. No. I've still got memory. Mm. Um, Well, that's annoying. 137 I freed up. That's not the right answer. It's off by one. Why are you off by one? Holy cow, I've got so many of these open right now. Um, where's the 157? Oh, you're on 158. Great. Um, not that. You. Yeah, so why is it? Why are you off? Oh, there's negatives. Of course. 33. Great. Don't print you. I I mean, this still is not a proper solution. Okay. Wow, that was horrible. Get rid of all of these. Yes, get rid of all of these. Yeah. So I'm not gonna be able to give a very intelligent answer for how to solve part two, because clearly I don't know how to do it. I offloaded the entire problem. Um, I'm actually annoyed at myself that I didn't think to offload it earlier. That's why I have the Z3 library, and it clearly gets the answer. Not exact. Okay, I stand corrected. It gets the answer super duper fast. It actually knows what it's doing, unlike me. Um, yeah, awful hack, all that stuff, go away. Like, look at that. Pretty much instantly goes through everything, gets the answer, and I was just waffling around forever. Um, over 1,000 people had this before me. So that's not a good showing for me. But let's talk about part one, because part one I actually understand, and part one isn't too bad. Part one, we get our data. We have buttons that will toggle uh, the states here, kind of like the light up games, the two-dimensional button games where you click a button, or you toggle a light, and the surrounding four lights toggle as well, and you want to turn all the lights on or turn all the lights off. So it's not too bad because we only have two states, so we can just keep track of what our target is, keep our initial state, and go through a bunch of iterations, a bunch of steps where we try every single button and we see what state we end up getting to from those buttons, uh, track those in new states, uh, and see, hey, is our target state in the new states? If so, great, we're done. Mark it as matched and break out. If it's not, then keep going until we find it. And just for efficiency's sake, if we've already handled a given state, don't check it another time because we've seen it before, and we have a more efficient path to get to that state. So that's part one. Part two is honestly a very interesting enhancement to this, where instead of two states on or off, we just keep incrementing voltage. Now, I had a number of ideas, and clearly none of them panned out. My last idea, which was actually making better progress than my other ideas, was treat this as a graph problem. Maybe I shoehorned it in because I've been yearning for a graph problem. And from each state in the graph, each voltage amount, figure out which buttons we can press, how far they'll go towards hitting our target voltage, etc., etc. And then I was trying to speed up the search by just instead of picking any random button and clicking it once, clicking or choosing the target voltage, the target index. That was in one case I tried furthest away, but ultimately I settled on the voltage here. Let's take this for example. For us to hit this voltage from zeros, we're at some point going to need to increment this to 12. We only have two buttons, and only one of those buttons handles a 1. So we're going to have to hit this some number of times being 12. And so by doing that, we also bump up the 0th button and the 3rd button. And the 3rd button also needs to be 12, so we're done with that. Then the 0th button is going to be up to 12. We need to hit that 13 more times, and we need to hit this 13 more times. So because we've handled this first, we've done most of our work, and we've reduced our search space. That was the idea here in these list comprehensions and this craziness that I was doing. That was getting further. It actually got up to somewhere around here before it just stalled. So yeah, that it was making more progress. Eventually, I whipped together this awful caching system where I would cache previous numbers because I wanted to parallelize it because I had no other ideas. Obviously, that didn't pan out. There is somehow an intelligent way to solve this, and I look forward to looking over the mega thread and feeling dumb as I see what I should have seen. But since I couldn't figure it out, we do have the Z3 library, or at least I do, and that's a efficient way to cheat in this sort of constraint equation problem. Just make a whole bunch of variables, add a bunch of constraints to an optimizer, and tell the optimizer to minimize the number of steps that we need. Check that we got a valid solution, and get out the number of steps that it took. All of this code is just encoding one of these lines, like this being encoded right there in what I have highlighted. Definitely not an elegant solution, because I'm offloading the entire thing. Uh, but at least there's some degree of intelligence in knowing how to use the Z3 library. And clearly, it took me forever and a day to even think to use it. So, yeah, uh, not a great showing from me at all because I got the answer, but I offloaded to another library to do it. Yeah, sorry for the incredibly long solve. I will hopefully do better tomorrow and hopefully not shoehorn in uh, graph logic where it clearly doesn't make sense. So, oof.